This is a key on the worksheet on solving rational inequalities. And for each of these three problems, these rational inequalities, make sure you show the work as presented in the class. And as we do this, just as you did with the lessons, we're gonna look at these steps as we go through the solution to these problems. Okay, so let's look at the first one. So the first one, you have the rational expression x plus 5 divided by x minus 6, and that is greater than 0. So remember, you want to solve these rational inequalities. And what we mean by solving these rational inequalities, just like you did equations, is that you want to find the real numbers for x that will make this left side, this rational expression here, greater than 0. And in the process, in the steps that we're using, in these steps here, you want to make sure that 0 is on this side, because we are using these particular steps where you're going to use a number line and you can use test points. All right, and so it's very important that you have 0 on this side. And you'll notice that in the problems you have 0 or a 0 is on the on one of the sides. In this case, it's all on the right-hand side. But there could be situations where you don't have 0 on that side. All right, but for us, it will be. Okay, so the first thing you want to do, the first step you want to do when solving these rational inequalities is to factor both numerator and denominator if possible. And you'll notice that in the numerator and the denominator, those are both linear factors, and the GCF in both cases 1. So you cannot factor these the numerator, nor can you factor the denominator. So then step number 2 is the first thing you want to do is you want to find the zeros. And we saw in our lessons that when you have a rational expression, the zeros of that rational expression, that one rational expression that you see here, the zeros of that rational expression is when the numerator is 0. So if you want to find the zeros, you're going to set that numerator x plus 5 equal to 0, and you're going to solve for x. So x equals negative 5. So that's your 0. That is the 0. Okay? And so the third step then is you want to find the values of the variable that makes the denominator 0. So in other words, where's this rational expression undefined? Well, remember, a rational expression is undefined when the denominator is 0. So we're going to set the denominator equal to 0. Remember what we're finding here, we're finding the undefined points. The undefined points. So let's go ahead and call it that. Undefined points. And so where's this rational expression undefined? It's undefined when the denominator is 0. So you set the denominator equal to 0, and you solve for x, so you get x equals 6. So that's your undefined point. Okay? Now, once you do that, in step number 4, you're going to put the zeros and the undefined points on the number line. And when I put these on the number line, always make sure that you put them in correct order. So negative 5, 6. So that should not be a problem because one's negative, one's positive. So let's put negative 5 here and 6 here. And what these, remember this one's my 0 and this is my undefined point. And what both of those numbers do, though, it divides this number line into 3 intervals. So from negative infinity to negative 5, from negative 5 to 6, and from 6 to infinity. All right, so it divides that number line. Those two numbers here divide the number line into 3 intervals, and it's those intervals that you need to use test points in to see which interval will give you the real numbers that will make this rational expression greater than 0. Now, before we go on, let's talk about this a little bit further. So we keep talking about this rational expression greater than 0. Well, no matter if I substitute values of x here, I want this rational expression to be greater than 0, meaning I want it to be a positive number. Okay, I want it to be positive. Okay, so this is strict inequality, so strictly greater than 0. So I want it to be positive. All right. Now, before we then determine our test points, let's go and determine whether these points here that I just put on the number line are solutions to this inequality. All right, so remember, undefined points are never solutions to this rational inequality, because that's where this rational expression is undefined. So automatically on 6, I'm going to always put, for the undefined points, I'm always going to put an open circle, so that cannot be a solution. The zeros may or may not be a solution depending on if you see an equal sign here. So since there's no equal sign, -5 will also be open circle. All right? And so now let's go ahead and do step 5. So step 5 is where we're going to test each interval to find the sign of the rational expression on each interval. So give me a number between -infinity and -5. So let's say -7. And always try and use integers. You won't always be able to, but choose integers that are within those intervals for your test points. So -5 to 6, an easy one to use is 0. And then from 6 to infinity, yes, let's use 7, +7. All right, now, we're almost done. All you got to do now is determine whether this interval is positive, this interval is positive or negative. I should say this, whether this interval is positive or negative, whether this interval is positive or negative, or whether this interval is positive or negative. Okay? Now, notice the work you have to do. You have to show this. This is what you're expected to show. All right, so let's go ahead and go back to the original. Well, this problem here, because we didn't factor it. Let me rephrase that. It could not be factored, so we have to resort back to this one. And I'm going to do the work right here. So in place of x, I'm going to substitute -7. And all you're doing is just determining the sign of each of those factors. Notice a factor in the numerator is x plus 5. The factor in the denominator is x minus 6. So -7 plus 5 divided by -7 minus 6. And all you're doing is just determining the sign. So a -7 plus 5 is a -2. So that's negative, right? A -7 and -6 is a negative number. It's in particular, it's a -13. But all you need to know whether it was negative or positive. And then we know that a negative number divided by a negative number is a positive number. Now, I'm going to put the word positive here. So what that means, what I just found, what this tells me is that if I pick any real number in that interval, so -10, -100.6, any real number in that interval, it's going to make any real number in here will make this rational expression a positive number, which is what I want. So that means, see the positive here, greater than 0 is positive. That means this is going to be a solution. That interval is going to be a solution. All right? So notice you expect to show the test points, and you're expected to determine whether that interval is positive or negative. And it has to be clearly indicated to get all points. All right, the next test point is 0. So go back up here again. So where we see the variable x, you're going to substitute 0. So 0 plus 5 divided by 0 minus 6. The numerator, 0 plus 5, that's positive. That's a positive 5. 0 subtract 6 is a -6. That's a negative number. A positive divided by negative is a negative. Now what that means is that any real number in that interval between -5 and 6, in that interval, any real number, -2.87 is in that interval. 2.994 is in that interval. 4.7777821 is in that interval. All those real numbers in that interval is going to make this rational expression negative. So that is not a solution because I want this to be positive. Then we go to 7. Do the same thing. 7 plus 5, in place of x, you substitute 7. 7 plus 5 divided by 7 minus 6. 7 plus 5 is positive. 7 minus 6 is positive. A positive divided by positive is a positive. So any real number in that interval is going to be a solution to this inequality because he's going to make this rational expression positive. So you're done. You just got to answer the question. So the solution will be from -infinity to -5 with parentheses because -5 has an open circle. That's not a solution. So -infinity to -5, parentheses, union, and then from 6 to infinity, parentheses 6 to infinity. And there's your solution. Okay? All right, notice the work. This, you got to show this. You have to show this to get all your points. All right, so that's number 1. So So, and by the way, what I found, you see, the solutions to this inequality, the solution to that inequality will be any number in this interval or any number in that interval. Okay? All right, so keep that in mind. And if you want to check it real quick just to show you, I'm not going to do it on all the others because the time here, but notice that 4 is not in that interval. So the question is, why is 4 not a solution? Okay, so let's ask that. So why is 4 not a solution? All right, let's go back to the original. We go back to our original problem, which is this. So where we see the variable x, I'm going to substitute 4. So I have 4 plus 5 divided by 4 minus 6, and I want to see if that's going to be greater than 0, right? Well, 4 plus 5 is 9. 4 minus 6 is negative 2. And the question is 9 divided by negative 2 greater than or equal to 0? Well, first of all, notice this is negative, right? That's a negative 4.5. Well, a negative 4.5 is not greater than 0. A negative 4.5 is less than 0. So that's why 4 is not a solution. And you could do the same thing with asking yourself this. Why is 9 a solution? 9 better be a solution, right? So let's see if that's true. So is 9 x equal 9 a solution? And so you go back to the original problem. In place of x, substitute 9, and you say, what we get? We have 9 plus 5 divided by 9 minus 6, and I want to see if that's going to be greater than 0. Well, 9 plus 5 is what's that, 14? 9 minus 6 is 3, and the question is that greater than 0? Well, first of all, that's a positive number, and that positive number is greater than 0, so that's a true statement, right? Okay, so that's all that is you're just trying to find the values of x, so any real number that will make this inequality a true statement. Okay, so let's get number 2. So number 2, we have this for number 2. All right, here's number 2. So we have x squared plus 2x minus 3 divided by x minus 2 is less than or equal to 0. All right, so again, notice that in our problems, you're going to have 0 over here. So that's always the easy kind. Notice this time, though, that my numerator is a quadratic expression. So in that case, I will probably be able to factor it, right? The denominator, that's a linear expression, and I cannot factor x minus 2. But I can factor that. So let's go ahead and do this. So let's go ahead and factor the numerator. So in factoring the numerator, that's going to be x plus 3 times x minus 1. So that's the numerator. Divided by x minus 2, less than or equal to 0. Okay? All right, now let's go ahead and find the zeros. Next step, find the zeros. So remember, the zeros to this rational expression is where the numerator is 0. We saw that in a previous lesson. You saw why that's true. We looked at a few examples to explain why, when finding the zeros, you're just using the numerator. So let's go ahead and take the numerator. So we're finding the zeros. So find zeros. So that's where we set the numerator equal to 0, right? And so you know that here I have two factors. Notice your factors are x plus 3 and x minus 1. You have two factors whose product is 0. So I'm going to set both of those equal to 0. And so I get x to be negative 3 and x to be 1. So those are your zeros, okay? Now let's find the undefined points. That is step number 3. So I have a rational expression, so it is possible to have undefined points. You just got to determine, well, where's that denominator equal to 0? So let's find the undefined points. And so you set the denominator equal to 0, and so solving for x, you get x to be 2. So I have 2 zeros and 1 undefined points. So now I'm going to put this on the number line, just like the previous problem, except this time I'm going to have 3 values on that number line that I have to look at. Make sure you put them in order. So negative 3 is going to be listed first, 1 is going to be listed next, and then 2 is going to be listed next. Okay? Notice that those 3 numbers divide the number line this time into 4 intervals. 4 intervals. So this time you have to check 4 intervals. In the previous problem, you just had to check 3 intervals. So notice the 3 test points that I used in parentheses. See the work? Okay. So this time will be 4. Now before I go on, we got to ask ourselves, those 3 numbers that I just put on there, are any of them solutions? Well, we know that the undefined point is never going to be a solution. So right away on 2, I can put an open circle. That's not going to be a solution. But is -3 and 1 going to be a solution? Well, remember how I got those. I got those by setting the numerator equal to 0. And notice there's an equal sign here, so that will be a solution. All right, so right away I'm going to put a closed circle on the zeros because of the equal sign. And make sure you understand why those are solutions. So for example, we're just going to do -3, let's say. So look carefully, -3. So why is -3 a solution? And in your mind you're probably saying, well, in the previous problem you said that 0 here was not a solution. But now you're saying these zeros are solutions. Well, remember, it has to do with whether you see an equal sign here or not. See, here you see an equal sign, here you do not. So make sure you understand why that equal sign plays a part here. So if x is -3, I want to show you something. I'm going to go back to the factored part here. So I get -3 plus 3 times -3 minus 1, right? Divided by -3 minus 2, and I want to see if that's, if that's less than or equal to 0. That's the question. Well, -3 plus 3 is 0. So my first factor here is 0. My second factor, -3 and -1, that's a -4. Divided by -3 and -2 is a -5. Well, and again, the question is that less than or equal to 0? Well, 0 times a -4 is 0. And then 0 divided by -5, and the question is that less than or equal to 0? Before I go on, see that's a 0 here, right? That better be a 0. Why? Because that's how you found your zeros. You found your zeros by setting this equal to 0. So these two numbers, when you substitute back in, will make the numerator 0. But here's what I want you to understand. 0 divided by -5 is 0, and the question is 0 less than or equal to 0? Well, 0 is not less than 0, but 0 equals what? 0 is what? 0 equals 0. So that's a true statement. That's a true statement because of that equal symbol. All right, 0 does equal 0. So that's why -3 is a solution. All right, so now let's go ahead and figure out our test points. So I need a test point between -5 up to negative infinity up to -3. So let's say -4. Between -3 and 1, try and use integers if possible. So let's say 0. 1 and 2, there are no integers between 1 and 2, so I'm forced to use another real number. So let's just use a decimal. So let's say 1.5. And then from 2 to infinity, let's just use 3. All right, so those are my 4 test points. So I'm going to go back for each of those, just like I did this, very neatly, just like I did this. Notice how neat this is. So remember, I need to see the word positive and negative, positive and negative, positive and negative, positive and negative on each of those. All right, -4. Go back to the factored part. It helps if you go back to the factored part. Now, you got to make sure you factor this correctly. Otherwise, all this work is going to be incorrect. So always go back to the factored part, though, and make sure it's factored correctly. So my first factor is x plus 3. So I have -4 plus 3 times. My second factor is x minus 1. So -4 minus 1 divided by, and then this factor is x minus 2. So -4 minus 2. All right, so let's see what we have. Let's look at that first factor. -4 plus 3 is a -1, so that's negative. Times -4 and a -1 is a -5, so that's negative, right? Divided by a -4 times a -2 is a -6, so that's negative. But look at the numerator. You're multiplying these two factors together. A negative times a negative is a positive, right? And a positive divided by negative is a negative. So what that means is that any real number in that interval right here from -infinity up to -3 will make this inequality, this rational expression, either one of those because they're both equivalent, this rational expression a negative number. And is that something I want? Is that going to be a solution? Well, look at what you have. You want this right here this rational expression to be less than 0, so that means negative, or 0, right? So those zeros, just to let you know, those zeros are these right here. Okay? So those are solutions, and then this interval is a solution because those real numbers make this rational expression negative, which is what I want. Less than 0 means negative. Okay, then we go to 0. So notice how neat this looks. Now we go to 0. So we do the same thing. 0 plus 3. So 0 plus 3 times 0 minus 1 divided by 0 minus 2. Okay? Now look at each of those three factors. 0 plus 3 is a positive number, right? It's positive 3. 0 minus 1 is a negative 1, so that's negative. 0 minus 2 is a negative 2, that's negative. A positive times a negative is a negative. A negative divided by negative is a positive. So any real number in this interval will make this rational inequality, either one of these, because they're both equivalent, a positive number, which is not what I want. I want it to be negative. Now let's go to this interval. Is this interval going to be positive or negative? Well, let's look. 1.5. So I have 1.5 plus 3 times 1.5 minus 1 divided by 1.5 minus 2. 1.5 plus 3 is a positive 4.5, so that's positive, right? You just got to look at your sign. 1.5 minus 1 is a positive 0.5, so that's positive. 1.5 minus 2 is a negative 0.5, that's negative. A positive times a positive is a positive, so the numerator is positive, the denominator is negative, and a positive divided by negative is a negative. So any real number in this interval will make this inequality, either one of these, a negative number, and that's going to be a solution. That's a solution, and that's a solution. And then finally, the last one, 3. Do the same thing. Wherever you see the variable x, substitute 3. So I get 3 plus 3 times 3 minus 1 divided by 3 minus 2. 3 plus 3 is a positive 6, so that's positive. 3 minus 1 is a positive 2, so that's positive. 3 minus 2 is a positive 1, that's positive. A positive times a positive is a positive. And then the denominator is positive, and a positive divided by a positive is a positive. So what that means is that any real number in that interval, if you had chosen any real number here, we chose 3, or I chose 3, but you could have chosen any real number in that interval, it would have made this, no matter which one you chose, it would have made this rational expression a positive number, which means that that's not going to be a solution because I want it to be negative or 0. So those are your two solutions, those two intervals. So your answer, your solution, you're going to say, and remember, always go from left to right. So from negative infinity to negative 3 with a bracket, right? On negative 3. Remember, for infinity, negative infinity is always parentheses. Union, and then the other one is from what? 1 to 2. So 1 bracket, 2 parentheses. All right, so that's important. Make sure I can see the bracket or understand it's a bracket, and make sure I understand that this is a parentheses. All right, so there's your solution. So the solution to the original inequality, so the real numbers of x that will make this inequality a true statement will come from these two intervals. Any real number that's in those two intervals. So very simple, not difficult at all. And so finally, number 3. So let's get number 3. All right, number 3, we have this problem. So we have this rational inequality, x minus 7, that's a 7, divided by x squared minus 7x plus 10 is greater than or equal to 0. All right, so notice, though, the work that needs to be shown. So don't be lazy with this. Make sure you show the work as it needs to be shown. See, all your test points in the work. Test point in the work. Your number line separated. The values are separated. You have test points in parentheses. You're telling me whether that interval is negative or positive. Okay? All right. Okay, so step number 1, remember, is to factor numerator and denominator. Notice, though, in this one, I can factor the denominator, so let's go and do that. So I have x minus 7. The denominator I can factor as x minus 5 times x minus 2. And then greater than or equal to 0. All right. So remember what we're trying to do. We're trying to find the real numbers or the real values of x that will make this expression, either this or this, they're both equivalent, greater than 0. Remember, greater than 0 means positive, so I want this to be positive. Or it can equal 0, so R is 0. So notice there's an equal sign. All right, so keep that in mind. That's what I'm looking for. So when we need to find steps 2 and 3. We need to find the zeros, and we need to find the undefined points. So let's talk about the zeros first. So find zeros. So to find the zeros, you're going to set the numerator equal to 0. So x minus 7 equals 0. So then x equals 7. So there's your 0. 7 is a 0. To find the undefined points, you're going to set the denominator equal to 0. X minus 5 times x minus 2 equals 0. So using the zero factor property, I'm going to set each of those factors equal to 0. X minus 5 equals 0. X minus 2 equals 0. So I get x to be 5 and x to be 2. So those are the undefined points. Just like the previous problem, I have 3 numbers I've got to put in the number line. So we put those numbers on the number line. All right. And let's put them in order. They're all positive, so it's very easy to put those in order now. 2, 5, and 7, right? So 2, 5, 7. Okay? All right, now keep in mind what you just found. You found the zeros and the undefined points, and those 3 numbers divide the number line into 4 intervals. And you have to determine which of those intervals will be a solution to this inequality. All right, so we got to find test points. Oh, before we do the test points, let's determine whether 2, 5, and 7 are solutions or not. Well, remember, undefined points are never solutions because that's where this rational expression is undefined. So that's 5 and 2. I'm going to put open circles. So 5 and 2. 7. So is 7 going to be a solution or not? Well, no, there's an equal sign, right? So it is going to be a solution. So put a closed circle there. All right? Okay, so now let's pick test points. So a number from negative infinity, between negative infinity and 2, 0 is nice. Let's use that. 2 to 5, use an integer if possible. There's only 2 integers available here, so let's say 3. 5 and 7, there's only 1 integer, so let's say 6. And then 7 to infinity, let's choose 8. All right, so those are my test points. So I'm going to go back to the factored part to test the sign of the factors, to determine the sign of the factors. So let's do the first one first. Okay, so where we see the variable x, you're going to substitute these test points. So the first one's 0. 0 minus 7 divided by, and then the 2 factors in the denominator, 0 minus 5 times 0 minus 2. 0 minus 7 is a negative number, so the numerator is negative. 0 minus 5, the first factor in the denominator, that's a negative 5, so that's negative. 0 minus 2, that's a negative 2, so that's negative. The denominator, well, first of all, notice the numerator is negative. Now the denominator, a negative times a negative is a positive. And so therefore, no matter which real number you chose here, whatever real number you chose, we chose 0, but no matter what you chose in here, you'll notice that rational expression is going to be a negative divided by positive, which is a negative. And so that means is that this, no matter what real number I put, no matter what real number is in that interval, is going to make this inequality either this or this. They're equivalent. It'll make that inequality a negative number, which is not what I want. I want to find the real numbers that will make this positive or 0. So we found the 0 one. That's this. We got to find the positive intervals here. All right. So let's do the next one, 3. So if x is 3, do the same thing. You're going to say 3 minus 7, 3 minus 5 times 3 minus 2. So 3 minus 7 divided by 3 minus 5, 3 minus 2. 3 minus 7 rather, up here, the numerator, is negative. 3 subtract 5, that's a negative 2, so that's negative. 3 subtract 2 is positive 1. That's positive. So the numerator is negative. The denominator, a negative times a positive is a negative. And we know that a negative divided by negative is a positive. So if I had chosen any other real number here in that interval, that fraction would have been positive. That rational expression would have been positive, which is what I want. So that's going to be a solution. So any real number in here will make this inequality a true statement. Now let's go to 6. Do the same thing. 6 minus 7 divided by 6 minus 5 times 6 minus 2. 6 subtract 7, that's a negative 1, so the numerator is negative. 6 subtract 5, that's a positive 1, so that factor is positive. 6 subtract 2 is positive 4, so that factor is positive. So we have a negative in the numerator. The denominator, positive times a positive, is a positive. And we know that a negative number divided by a positive number is negative. So that means that any real number in that interval from 5 to 7, between 5 and 7, is going to make this inequality, either one of those, a negative number, which is not going to be a solution. So that interval is not a solution. Let's go to the next one, the very last one now. So we're almost done. If x is 8, do the same thing. Substitute 8 for x. So I get 8 minus 7 divided by 8 minus 5 times 8 minus 2. 8 subtract 7 is a positive 1, so the numerator is positive. 8 subtract 5 is a positive 3, and then 8 subtract 2 is a positive 6, so that's positive. The numerator is positive. The denominator, positive times a positive is a positive, and then a positive divided by a positive is a positive number. So if I had chosen any real number in that interval, that rational expression here, either one of those, would have been a positive number, which then makes this a solution because that's what I want. I want greater than 0 or 0. All right? So these two are my solutions along with that 7. So your solution, and remember you always go from left to right, from smallest to largest. So so my solution would be from parentheses 2 to 5 parentheses 2, 5 parentheses, union, and then bracket 7 to infinity. All right? So those are your solutions. All right? So that is the key. That is the key to this worksheet, the worksheet on rational inequalities.